Section 2.6 is about linear programming, and what we're going to do is we're going to be given some certain information, and we're either going to want to maximize a profit or minimize cost. And it's pretty interesting, and yes, it's going to be story problems, but hey, that's what math is all about. And you complain sometimes about not being able to use math in real life, and here are now examples to help answer that question. When are you going to use this? If you're ever a business owner someday, this is probably going to be a helpful tool for you. All right, so here we go. It says Joe Washington has a choice of planting a combination of two different crops on 20 acres of land. For crop A, seed costs $100 per acre. For crop B, seed costs $200 per acre. Government restrictions limit acreage of crop A to 15 acres, but do not limit crop B. Crop A will take 15 hours labor per acre at a cost of $5.60 per hour, and crop B will require 10 hours of labor per acre at $5 per hour. If the expected income from crop A is $600 per acre and from crop B is $520 per acre, how should the 20 acres be apportioned between the two crops to maximize profit? Now that sounds like a ton, and there is a ton of information in that. It took me almost a minute to read. All right, but let's go ahead and let's break it down a little bit. Now, I have a graph here, you've noticed, and in that graph, all right, we're going to graph our acres and stuff. So what we want to do is we want to write constraints, is what they're called. Constraints are what's limiting our numbers. What are we limited by? All right, and there's a bunch of things we're limited in here by, but what we want to do is we want to just deal with the acres. We don't want to deal with anything that has to do with money right now. And because what we're going to happen is when we get to the profit part, that's when we'll start taking information about the money. All right, so first of all, let's just talk about the crops. What kind of constraints do we have the crops? Well, obviously, we can't have less than 0. I said let X be the number of acres for crop A and Y be the number of acres for crop B. So we obviously can't have less than 0 acres for crop A. We can have more, and we can have 0 acres of it, but we can't have less. And then for the same reason, we can't have less than or equal to 0 acres of crop B. We have to have more than that, so Y is greater than or equal to 0. So we've already set 2 constraints. Basically, the constraints that we've set are we have to be in the top quadrant number 1. All right. What other constraints do they give us? Well, we're going to have a combination of X crops and Y crops in order to get 20. So X plus Y has to be less than or equal to 20. We don't exactly have to plant the full number of crops, but we certainly can. So that's where I came up with that equation. X plus Y, that combination has to be either 20 acres or smaller in acres. We're gonna plant a combination of 20 acres. There's a couple more constraints on there. Let's see. 2 different crops. We did that. That's 2 different crops. That's where we got our X plus Y is less than or equal to 20. Here, this is dealing with dollars. We're going to forget about that for now. But here, in this sense, it says government restrictions limit acreage of crop A to 15 acres, but do not limit crop B. We said crop A was X. 15 acres. So we can plant no more than 15 acres. So X has to be less than or equal to 15 acres. All right, so we have our constraints now. Let's go ahead and let's graph. I don't think there's anything else in there. I don't think so. Nope. So let's go ahead and let's graph this. We would subtract X over. We're going to start at 20. And it looks like we are going to go down 1 over 1, or it can go down 1, 2, 3, 4, 5, and over 1, 2, 3, 4, 5. 5 over 5 is the same thing as 1 over 1. And I can continue doing that down here. And it's a solid line. And it says it has to be less than. So therefore, it's going to be shading down. If we pick 0, 0, that's a point not on this line. 0 plus 0 is less than or equal to 20. That's a true statement. We're going to shade down in here. There's also one more. X has to be less than or equal to 15. We know when anything says X equals, it's going to be a vertical line. So this is 5, 10, 15. It's going to be a vertical line at X equal to be 15. And it says it's less than, we'd have to shade in here. So we have all our constraints graphed. And we learned in the last section that we would take the vertices of these graphs, and that would tell us our minimum, maximum, and so forth. So let's go ahead and let's get our min and our max and all that written down. So look at our vertices. Right here I have 0, 20 would be 1. I have, let's see, this is 5, 10, 15, and then up 1, 2, 3, 4, 5, 15, 5. So I can plant 15 of crop A and 5 of crop B. And I also have these constraints down here. I have 15, 0. And that should be it. That's the 4 corner. Oh, and then obviously I have 0, 0. I could plant nothing. But I'm guessing by planting nothing, unless we're completely losing money on the whole deal, isn't going to be our answer. All right. So let's go ahead and let's scroll down a little bit. Hopefully you copied down those points because I just lost them by how this thing has to scroll down. Oh, maybe not. All right, the next thing says, right, I'm going to go ahead and erase this stuff here. My graph is now off because I scrolled down. Don't worry about the graph. The next part now says, write an expression for profit, income minus cost. All right, so we're going to have two expressions. We're going to have one for my A crop and one for my B. So let's go ahead and let's write crop A. It talked about profit. The expected income from crop A is $600. So my income would be $600. And we got to subtract everything it's going to cost us. All right. So it's going to cost crop A will take 15 hours of labor per acre. So it'll take us 15 hours of labor per acre. So that's at $5.60 per hour. So we're going to have to write our equation. That's going to be 15 hours times $5.60 for every acre of that we have. And then in here also it says that seed costs $120, so we're gonna have to subtract our seed costs as well, so minus $120. So our overall profit function for this, if I combine like terms, our profit is $600 per acre, so 600x minus 15 times 560x minus 120. If I combine like terms in there, my profit for every acre that I plant, I'm going to make $396 for every acre that I plant. So 396x for crop A. For crop B, it says that we're going to profit. It says expected income is $520. So $520 minus now everything that it costs us. So it's going to cost us for crop B, seed cost $200. So we're going to make $520 per acre. So 520. Sorry, Y, that is B stuff. The B seeds, 520Y minus, it costs us $200, 200X for seed. And then it's going to cost us 10 hours of labor times $5 an acre. So 10 times 5 per acre. So 10 hours of labor times $5 per hour. So that's $50 per acre, basically. It's going to cost me in order to work this thing. So when I add like terms, I'm going to get 200 and, sorry, I keep writing X. These should be Y's. We're dealing with crop B. I'm sorry about that. This should be 270Y. So my profit function means my profit, P, is going to be 396. I make $396 per acre for A, for crop A, plus $270 per acre for crop B. There is my profit, and in order to maximize profit, all we need to do now is we need to plug in these points in order to maximize our profit. All right, so obviously if I plug 0, 0 into there, I'm going to get 0. That's not going to be a max probably. All right, if I plug 15 into here, 15, 0, this guy right here, I get 396 times 15, which is 5,940. If I plug this number in, 15 for X and 5 for Y, so 15 acres of A crop, 5 acres of B crop, I get 7,290. And if I just plant 20 acres of the B crop, I get 5,040. Or sorry, 5,400. So all I did is I plugged these in into each equation. They want to know what our maximum was. We're going to maximize our profit. If we want to make the most money, we're going to plant 15 of the A crop and 5 of the B crop because that gave us $7,290 in profit. That seemed like a lot. You might have to rewatch that example and try to complete some of it yourself. I know I got a little bit wordy there. So we maximize our profit there. In feasibility, it says when constraints of a program cannot be satisfied simultaneously. So basically, if we have some constraints that go, maybe we have a line and it says this one has to be greater than or equal to that way, and this one's got to be less than, but nothing overlaps, that's infeasible. We can't do anything about it. And unbounded, if a region defined by constraint is infinitely large, notice my area up here, there's nothing here that cuts this off. It says it's just greater than that. That is unbounded. There's nothing that kind of goes off into infinity. Okay? All right. So, one more example for you. It says the AC Telephone Company manufactures 2 styles of cordless telephones, deluxe to standard. Each deluxe telephone nets the company $9 in profit, and each standard telephone nets $6 in profit. Remember, we're going to save that profit stuff for later. Machines A and B are used to make both styles of telephones. Each deluxe telephone requires 3 hours of machine time and 1 hour of machine B time. Machine A, sorry, that should be machine A up there. Each standard telephone requires 2 hours of machine A time and 2 hours of machine B time. An employee has an idea that frees 12 hours of machine A and 8 hours of machine B. Determine the mix of telephones that can be made during the free time that most effectively generates profit for the company. So let's go ahead and let's define the variables. Let's say X is the number of deluxe phones. So deluxe. All right. And we're going to make Y the number of standard phones. All right. Let's go ahead and write our constraints again, and we'll graph it. So our constraints, remember, we're not dealing anything with profit here. All right. So now we say machine A and B are used to make both styles of telephones. So machines are limited. So let's go write a machine A and a machine B equation. Machine A, machine B. Machine A. All right, it says each deluxe telephone, that's all right. Each deluxe telephone requires 3 hours of machine A time. So 3 hours for each deluxe on machine A and 1 hour on machine B. So 1x because we made deluxe X. All right. Then it says each standard phone requires 2 hours of machine A time, so plus 2 hours of machine A, so standard is Y, so 2Y. And it requires 2 hours of machine B time, so 2Y there. An employee has an idea that frees up 12 hours of machine A time, so this should be 12 hours or less than or equal to 12 hours. And 8 hours of machine B, less than or equal to 8 hours of machine B. Determine the mix of telephones we made and most effectively maximize our profit. All right. So obviously we can't make less than 0 telephones, right? So we're also going to have the constraints of X has got to be greater than or equal to 0, Y has to be greater than or equal to 0. We're always going to be in the first quadrant when we're dealing with real life stuff as far as making things. So we're in the first quadrant. We're up this way here. All right. Let's go ahead and let's graph machine A. If I were to subtract my 3x to the other side and divide by 2, I would have Y is less than or equal to negative 3x, 3 halves x, plus 6, because I divided by 2. So I'm going to go up 6. I'm going to go up 1, 2, 3, 4, 5, 6. Put a dot right there. I'm going to go down 1, 2, 3 into the right 1, 2. Down 1, 2, 3 into the right 1, 2. And I'll be shading underneath that. All right. And let's go machine B. If I bring this 1x to the other side and divide by 2, I'll have y is less than or equal to negative 1/2 x plus 4. So I'm going to go up 4. I'm going to go, let's make this one in blue here. Go up 1, 2, 3, 4. And I'm going to go down 1 to the right, 1, 2. Down 1 to the right, 1, 2. Down 1 to the right, 1, 2, and so forth. All right, so if I go ahead and draw my lines back up here, connect my dots, we're going to have a closed polygon here. And it looks like we have one vertex here, 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 and right here. They also intersected there. All right, now obviously these are all less than or equal to. We're shading down here. Here's our available solutions. All right. So we're going to use that. I'm going to go ahead and get rid of these so we don't have to erase things like I did last time, like I messed up last time. All right. Now let's go ahead and write our profit function. Write an expression for income. Our expression for income says if the company nets $9 in profit for each deluxe, so 9x, deluxes are x, plus, and it nets $6 for each standard. So my profit function is 9x plus 6y. So we have our, sorry, that's not one. We have our vertices, which would be here, which would be 0, 1, 2, 3, 4. So 0, 4 is one option, 0, 4. And we have, let's see, 1, 2, 2, 1, 2, 3. So 2, 3 is one option. I can make 2 deluxe. Come on. 2, 3 is one option. And then I also have another one at 0, or at 1, 2, 3, 4, 0. There's another option, and obviously we have 0, 0. 0, 0 is probably not going to play into our maximized profit. We can tell you that already. All right, in order to figure out our maximum profit, let's go ahead and let's plug these in. X is 0, so for this case, if we plug it in, we get 4 times 6, which is 24. 2, 3, so if I plug 2 in for X and 3 in for Y, I get 18 plus 18, which is 36. If I plug 4 in for X and 0, I also get 36. And if I plug 0, 0, I'm obviously getting 0. So looks like our company actually has options. We can either make 4 deluxe telephones and no standard phones, or we can make 2 deluxe phones and 3 standard phones. So we have options. We can have 2 and 3, or we can have 4 and 0 to maximize our profits. So I hope this helps. I know this section is tough, and a lot of people have questions on it. Try to understand this video. If you don't, rewatch it and then come ask me for help. I hope this helps, and we'll see you in class.